Chapter 3. The discovered mathematical perfection of the universe. We begin with a thought from physicist Roger Penrose. Mathematics is not just a tool for understanding the universe, it is a very deep part of the structure of reality itself. And as mathematician and philosopher John Lennox observes, the elegance of mathematics is not only in its power to solve problems, but also in its ability to describe the underlying structure of the universe. To me, that is evidence of a creator who designed it all. From the moment we open our eyes to the world, patterns surround us, patterns that speak a silent language of order and beauty. Whether it is the symmetry of a butterfly's wings, the rhythmic waves of the ocean, or the spiral of a seashell, these patterns hint at a deeper structure underlying reality. Mathematics, often thought of as a purely abstract pursuit of numbers and formulas, is in fact the key to unlocking this hidden order. It is not confined to textbooks or classrooms. It is alive in the very fabric of creation, waiting to be noticed by those who are curious enough to look. What strikes me most about mathematics is how it reveals truths that are at once simple and profound. These truths are not hidden. They are there whether in nature, in the cosmos, or in the intricate architecture of life itself. Mathematics provides a lens through which we can understand the universe, offering insights that go beyond human imagination. It is both universal and timeless, a language written into the cosmos long before humans existed to interpret it. Among the most captivating mathematical patterns found in nature is the Fibonacci sequence. This is a series of numbers where each number is the sum of the two that come before it: 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. At first glance, it seems like a simple curiosity, a playful game of numbers. But look closer, and you begin to see it everywhere. In the world of botany, this is known as phyllotaxis, the study of the arrangement of leaves, seeds, and petals. If you look at a sunflower, you will notice that the seeds are arranged in two sets of spirals, one winding clockwise and the other counterclockwise. If you count these spirals, you will almost always find two consecutive Fibonacci numbers, perhaps 34 and 55, or 55 and 89. This is not a mere aesthetic choice by the plant. It is a masterpiece of engineering. By following this mathematical arrangement, the sunflower ensures that its seeds are packed together with the highest possible efficiency, leaving absolutely no wasted space. Furthermore, the leaves of many plants grow at an angle of precisely 137.5 degrees relative to the one below it. This is known as the golden angle, derived from the golden ratio. Why this specific number? Because it is the only angle that ensures no leaf perfectly overlaps the one below it, allowing every single leaf maximum access to sunlight and rain. This level of biological foresight suggests that the math preceded the plant. Closely related to the Fibonacci sequence is the golden ratio, roughly equal to 1.618, represented by the Greek letter phi. This ratio appears when you divide one Fibonacci number by the one before it. It creates a proportion that the human eye perceives as inherently right or beautiful. Ancient Greeks designed the Parthenon with this ratio. Renaissance masters like Leonardo da Vinci applied it to the proportions of the human body in the Vitruvian Man. Yet the golden ratio was not invented by artists. It was discovered by them. It is present in the spirals of a nautilus shell, the curve of a breaking wave, and even the proportions of the human face. The repeated appearance of these patterns across both human design and nature raises a striking question. Why should these patterns occur so consistently? Are they mere coincidences, or do they hint at a deeper order embedded in creation? John Lennox described these patterns as brushstrokes on the canvas of the universe, reflecting a rational and purposeful design. As we step deeper into the structure of reality, we encounter fractals, endlessly repeating patterns that look the same no matter how closely you zoom in. In nature, they are everywhere. The jagged edges of coastlines, the branching of trees, the veins of leaves, the spiral of a nautilus shell, and even the delicate structure of snowflakes. Fractals are not merely beautiful, they are a mathematical solution to a physical problem. Consider the human lung. To keep a human being alive, the lungs must absorb a massive amount of oxygen. To do this, they need a vast surface area. If our lungs were simple balloons, they would have to be the size of a room to function. Instead, they use a fractal branching pattern. One large airway branches into 2, which branch into 4, then 8, and so on, through 23 levels of branching. This allows a surface area roughly the size of a tennis court to be packed into a small, portable chest cavity. The same principle applies to our circulatory system. Thousands of miles of blood vessels are packed into our bodies using fractal geometry to ensure every single cell receives nutrients. Even the way a tree branches follows this fractal logic to maximize the catchment area for sunlight while maintaining structural integrity. Everywhere we look, fractal patterns optimize function while creating awe-inspiring beauty. This suggests that the universe was designed by an efficient engineer who used mathematics to solve the problems of space and energy. Nowhere is the precision of mathematics more striking than in DNA, the molecule of life. We often think of DNA as a biological substance, but it is more accurate to think of it as a digital code. While our computers use a binary system of zeros and ones, DNA uses a quaternary system of 4 chemical bases: adenine, thymine, cytosine, and guanine. The amount of information packed into each tiny cell is staggering. Over 2 meters of DNA are folded into a microscopic nucleus without ever becoming tangled or knotted. How is this possible? It turns out that DNA uses a specific mathematical folding pattern known as a Hilbert curve. This fractal-like folding allows the code to be incredibly compact while remaining perfectly accessible for the reading machinery of the cell. Furthermore, DNA contains error-correcting mechanisms that mirror the checksums used in modern computer science. When the code is copied, enzymes proofread the sequence to ensure accuracy. Francis Collins, one of the leaders of the Human Genome Project, described DNA as a language written in code. This language is so precise and sophisticated that it mirrors systems human engineers spend years attempting to replicate. The consistency and reliability of DNA's structure and function point to an underlying intelligence woven into the design of life, far beyond the reach of random chance. If the patterns of life and nature inspire awe, the motion of the heavens has fascinated humans for millennia. The study of planetary orbits, tides, and gravity all reveal a universe governed by precise mathematical laws. No figure embodies this revelation more than Sir Isaac Newton, whose work bridged human curiosity and cosmic order. Newton formulated the laws of motion and universal gravitation, showing that the same principles governing an apple falling from a tree also dictate the movement of planets. He described the universe as operating with clockwork precision, each celestial body following predictable paths determined by exact mathematical relationships. What is remarkable is that Newton saw this order as evidence of a creation. He wrote that the harmony and predictability of the cosmos pointed to the most beautiful system of the sun, planets, and comets, as the work of an intelligent and powerful being. To Newton, mathematics was not just a human invention, but a window into creation. He believed that the universe was so finely balanced that a creator must constantly sustain the laws of physics to prevent the system from falling into chaos. Newton's insight into gravity also revealed hidden harmonies in planetary motion. Planets orbit the sun in ellipses described by precise ratios and speeds. Moons and satellites, like those of Jupiter, display orbital resonances, locked in numerical relationships such as 1 to 2 to 4 that prevent gravitational interference. The precision is staggering. Even tiny deviations in gravitational constants would destabilize planetary orbits and make life on Earth impossible. Newton recognized that such perfect calibration suggested a universe designed with intention. What deepens this mystery is that mathematics does not merely describe what we can already see, it routinely predicts what we have yet to discover. Time and again, physicists have sat at desks working purely with abstract geometry and equations, uncovering mathematical truths that seemed to have no physical reality, only for experimentalists to find them decades later out in the cosmos. Black holes, gravitational waves, and subatomic particles were all mathematical certainties on paper long before they were observed by human technology. If mathematics were simply a human invention, a tool we manufactured to organize our thoughts, it could never possess this extraordinary predictive power. It acts not as a mirror reflecting our own minds, but as a map tracking an objective reality that was laid down before us. This brings us to a profound philosophical question. Why does math work at all? In 1960, the physicist Eugene Wigner wrote a famous paper titled The Unreasonable Effectiveness of Mathematics in the Natural Sciences. He argued that the fact that mathematical formulas, which are products of human thought, can perfectly predict the behavior of physical objects is a miracle that we neither understand nor deserve. If the universe were a random accident, there is no reason why it should be comprehensible. Our brains should have evolved only to find food and avoid predators. They should not be capable of understanding the curvature of space-time or the internal mechanics of a star. The fact that the universe is written in a language we can read implies that we were meant to read it. Mathematics is the bridge between the human mind and the cosmos. It shows us that the universe is not chaotic, but orderly. That beneath apparent complexity lies elegant simplicity. As Einstein famously remarked, the most incomprehensible thing about the universe is that it is comprehensible. As we step back from the intricate details, from the spirals of sunflowers to the orbits of planets, we see a remarkable picture. Mathematics is not an invention, it is a discovery. It is the language of creation, written into the cosmos long before we arrived. From the microscopic world of DNA to the vast expanse of galaxies, the universe displays harmony, balance, and astonishing precision. The Fibonacci sequence, the golden ratio, fractals, symmetry in physics, and fine-tuned constants all point to a cosmos that is intelligible and coherent. These patterns do not merely facilitate life, they allow us to understand life and the universe itself, suggesting a reality designed with intention and intelligence. In recognizing the pervasive presence of mathematical order, we are invited to glimpse the hand of a creator. This creator, having woven mathematics into the very fabric of reality, provides a universe that is not only habitable, but intelligible, accessible, and breathtakingly beautiful. The universe challenges us to consider that behind all existence lies a deliberate origin. Mathematics proves that the cosmos is not a silent accident, but a grand symphony of logic, proportion, and purposeful design.